I mean, what are your thoughts on life after death? Because again, I'm going to quote you, and I've got to try and find. I've got a whole list of quotes here. But you say life is a conduit through which energy in the universe passes. So, say a human, an animal, a plant dies, where is that energy going?
Yeah, does things.
All right, Cameron, also in year 2, wants to know if you can describe how big the biggest star in the universe is.
Oh, that's a good question. I don't know the figure for the biggest star, but one of the biggest you can see with the naked eye, actually, is Betelgeuse, or Betelgeuse in Orion. And that's the red star in the constellation of Orion. I sort of want to say, but I can't because the orientation's different here, but it's a top left, but it's not. It's going to rotate it over.
Just tilt your head. Yeah.
Go and find Betelgeuse. It's a red star in Orion, the shoulder of Orion. And what's interesting about that is if you put it where the Earth is, then it would extend out pretty much to the orbit of Jupiter, I think even beyond the orbit of Jupiter. So if you imagine how far it is to Jupiter, that would be orbiting inside the star. And it's so big that we can see sunspots on the surface with telescopes here on Earth. So it's a vast star. But that's a star at the end of its life that's swollen up. That isn't, however, the biggest. So what we should probably do is that I should go onto the internet and look up. I don't have in my head the number for the most massive star or the biggest star, but there are stars that are really literally the size of solar systems.
There may be even the pop 3 stars. I was thinking those early, very first stars.
Yeah.
10,000 times the mass of our sun, absolutely enormous objects, but we've not been able to see them yet.
Yeah, well, they have very short lifetimes. That's the thing. So the more massive the star is, so you're talking about, as you said, a star, let's say 10,000 times the mass of the sun, then it has to burn its fuel extremely quickly to stay up against the force of gravity. And so they live for millions of years, actually, the lifetime, not billions of years. So they're very, very, very short-lived, the really massive stars in the universe.
Okay, so lots of students from around Australia have asked how many stars there are in the universe. But as a follow-up, how many do you think we will be able to see on the Stargazing Live attempt?
So the number of stars you can see, first of all, is actually only a few thousand, I think. It obviously depends on how big the telescope is that you have.
It's Sputnik, right?
I'm waiting for a number.
I'm going to go with 1.
So that launched, literally and figuratively, the space race.
Right.
NORAD is tracking this.
As well as Santa?
They do track Santa.
I thought that Santa was their only job.
In addition to protecting the free world, they track Santa.
They track Santa.
Yeah.
Right.
Yeah, they got to make sure nothing knocks him out of the sky.
Well, because, listen, let's be honest, once he starts flying near Russia, it's very possible it could happen.
They get all the presents.
Yeah.
It rains down the presents. The world as we know it is deeply infused with spaceborne assets, empowered by the fact that we have satellites orbiting above us.
So true.
Let's get started. Brian, we have questions from year 2 in Salisbury Primary School. Shakira asks how the moon was made.
That's a good question, which is that it was made in an impact. So very early on in the life of the solar system, so let's say 4.5 billion years ago or so, we think that a planet about the size of Mars collided with the young Earth. Now, as often is the case with science questions, there's not complete agreement, but there is a theory with which most people agree. And it's a glancing blow, actually, which caused a lot of rubble to go out into space, formed momentarily a ring around the Earth, somewhat like the rings around Saturn.
I'm just wondering, in your theory, what kicks off this chain of eons and what ends this chain of eons, or is that the wrong question?
No, it's a good take. Call it chain of eons, it's fine. Well, you there needn't be anything. Maybe it keeps on going forever. I don't know. I have no answer to that question. But it's perfectly reasonable within this picture to say this chain is just eternal. There is no beginning. There will be no end.
How do you dodge? We talked about Stephen's singularity theorem based on your singularity theorem earlier. How is that dodged? Why does there not have to be a singularity in our past?
Well, you see, the singularities, that particular one, you see, is only, you have to distinguish the ones in black holes, because the singularities in black holes basically are irrelevant in the sense that they're in the black holes. The black holes evaporate away. Okay, there might be a little tiny singularity when the black hole goes pop at the end, but that's so tiny. I mean, okay, it's a bit of a pop. It might not be good, be too close to that pop, but it's not
quite a big pop, isn't it?
It's well, depends.
Yeah, I mean, it's what is life? I mean, that's a very good question, by the way. The answer is we don't really know. That there are two very famous books on the reading list.
The reading list is immense.
One is called What is Life by Erwin Schrödinger, which was a very famous book in the 40s that sort of predicted the existence of DNA, which was discovered later. A great friend of mine, actually, Sir Paul Nurse, who's got a Nobel Prize, who runs the Francis Crick Institute here, or founded it in London. He wrote a book recently called What is Life, which is brilliant, from a Nobel Prize winning biologist. And he ultimately says that we don't really know, but you can pin some things down. So one, as you said, is it's something that happens. It's that there's energy, a flow. By energy, I mean, what do? We burn food in oxygen. And if we stop burning food in oxygen, then we die. So there's an energy in the way of steam engine. There's that part of it. And then there's information. It processes information as well. So that's what we do. So there's an information component and an energy component. But the point is, it just at a fundamental level, it's no different to something like a computing device, in the sense that it obeys these basic physical laws, which are, there's got to be a source of energy, and you've got to be able to do things, and your structure remains and things like that. So that would imply that it's the same as if your iPhone will stop processing information if you take the battery out.
And their orbits and this sort of thing. And not until early 70s does NORAD publish the data on these satellites. And that's when Donald Kessler said, if this keeps up and we start loading orbital space with these objects,
right,
things could happen here that we know happen in the asteroid belt. He thought to himself, if the same thing happens here, it would probably happen on a shorter timescale, because the orbital belt is not as large as the asteroid belt. And so you don't need as many satellites as you have asteroids to repeat the same phenomenon. So he wrote a paper exploring this idea. Satellites are being launched at an exponential rate. Okay? So October 4th, 1957, there was one satellite. October 4th, 2024, 7,000 satellites. Not all of them operational. About half are dead.
Well, see, there's the problem. We're leaving our junk in space. Space junk.
That's not the only kind of space junk. Was it 2009? There were 2 satellites that actually hit each other.
Oh.
Yes.
I did not know
that
this.
Actually happened. Okay? Now, consider, if all satellites are going in the same direction, most are going west to east around the Earth, then they're not really in as much risk of hitting each other.
Yeah.
So it's dead. It's a dead iPhone then. Admittedly, you can bring it back to life, so it's probably...
The exact date, I think something like 4.5 billion years ago. It's very, very early, very soon after the Earth formed.
I think maybe 200-300 million years after we were beginning to form.
Yeah, so...
All right, Cameron, also in year 2, wants to know if you can describe how big the biggest star in the universe is.
Oh, that's a good question. I don't know the figure for the biggest star, but one of the biggest you can see with the naked eye, actually, is Betelgeuse, or Betelgeuse, in Orion. And that's the red star in the constellation of Orion. I sort of want to say, but I can't because the orientation's different here, but it's a top left, but it's not. It's going to rotate it over.
Just tilt your head. Yeah.
Go and find Betelgeuse. It's a red star in Orion, the shoulder of Orion. And what's interesting about that is if you put it where the Earth is, then it would extend out pretty much to the orbit of Jupiter, I think even beyond the orbit of Jupiter. So if you imagine how far it is to Jupiter, that would be orbiting inside the star. And it's so big that we can see sunspots on the surface with telescopes here on Earth. So it's a vast star. But that's a star at the end of its life that's swollen up. That isn't, however, the biggest. So what we should probably do is that I should go onto the internet and look up. I don't have in my head the number for the most massive star or the biggest star. But there are stars that are really, literally the size of solar systems.
Not a good analogy, because you. So, and that might